All right, in this section, 1.4, surface area of right pyramids and right cones, we're going to look at how to determine the surface area of a right pyramid or a right cone. Now, a right pyramid is called a right pyramid because the perpendicular height from the top of the pyramid to the center of the base is at a right angle. And pyramids come to points, and we name the pyramids based on the shape of the base of the pyramid. So this would be a hexagonal pyramid, whereas this one would be a square-based pyramid. A cone comes to a point as well, just like a pyramid, but it has a circular base, like this. So within them, this H is the distance from the top point down to the middle. H, this we call our perpendicular height. And this is important for volume calculations, not so much for surface area calculations. The slant height here is more important for surface area calculations. So S is the slant height. The slant height runs from the point, from the peak, down through the middle of the face to the base. So it goes along the outside of the pyramid. Now, as you can see here, we have the perpendicular height right here. That's important for volume. Then here is one of the triangle faces. And the slant height runs down the center of the face. Now, pyramids, you should be able to unfold a pyramid into its net shape. Like this. And if it's a square-based pyramid like this, all of these triangles have the same size. So we just need to figure out the area of one of these triangles. And the slant height is important for figuring out the area of the triangle. Right? And then there's this area of the square. And area of the square is easy. It's just base times length times width, or base times base. In a right cone, here's our right cone as well. We again have the perpendicular height right here. It's from the peak down to the center of the circle. The slant height is from the peak to the edge of the cone. The radius is right here from the center to the edge. Now, I hope that you can see from this picture very clearly that there's a right triangle right here. And we can use Pythagoras' theorem, if we're given the radius and the height, to determine the slant height, using h squared plus r squared is equal to s squared. Because the slant height, which is right here, is for surface area. The perpendicular height right here is for computing volume. We're not doing volume today. We're just doing surface area. All right. A regular tetrahedron is a shape with 4 equilateral triangle sides. So there's 4 equilateral triangle faces, You could call this a triangle base pyramid. Now we need to identify something called the lateral height area. Sorry, the lateral area. The lateral area in a pyramid is going to be the area of the triangles. So there's 4 triangles on this, just the area of the triangles up here. So in this one, it's just the area of the triangles. In our cone, the lateral area is just the area of this curved part. All right, so that's what lateral area. The bottom is called the base. That's the area of the base. There would be the area of the base. All right, so let's talk about formulas. The surface area of a pyramid. There's no real formula for the surface area of a pyramid. We need to determine the area of the triangles using the formula. Area of a triangle is equal to base times height divided by 2. If it's a square-based pyramid, so the bottom is a square, then all the triangles are the same. If it's a rectangular-based pyramid, then we have 2 triangles that are the same and 2 other triangles that are the same. Then we need to figure out the area of the base. And typically right now, it's going to be either a square or a rectangle, and that's just length times width. For the surface area of a cone, a cone looks kind of like this. There's the slant height, there's the radius. So our surface area is equal to pi r squared. This is the base circle. We sometimes leave the base circle off. Plus pi rs. This is the lateral area. So sometimes we'll cut the base circle out and we won't do the base circle because we just want the lateral area. Sometimes you have to do both of them. All right, lastly, when you're finding the slant height from the perpendicular height, if we have our, usually we do this with a cone, but we can also do this with a pyramid. It's the same thing. Height, here's the perpendicular height, here's the radius, here's the slant height. The height squared, perpendicular height squared, plus the radius squared is equal to the slant height squared. So we just need to solve the Pythagorean theorem for this right triangle. All right, so there's some basics there. In the next video, we'll get on to the example problems.